So far, we've talked about the different information that scientists need to understand fish stocks. In this section, we're going to look at how scientists collect this information. An index of abundance is probably the most critical measurement feeding into stock assessments. Without a good index of abundance and data on age and length, it's impossible to have quality assessments. People refer to this as shit in equals shit out, meaning that if your data is crap to start with, then the results are also going to be crap. There's two different categories of fishing data: fisheries dependent data and fisheries independent data. First, let's look at fisheries dependent data. This is information that's either collected by the fishermen or by observers sampling commercial catches. Most commercial fisheries record catch in logbooks. These logbooks have information on location, depth, date and time, and how much fishing effort was used to take the catch. From this, scientists can learn about distribution and abundance, depth range, and how much the species moves around. In fact, most of our knowledge of fish distribution over space, time and depth has come from logbooks. Scientists also use logbook data to calculate catch rates, which they use as an index of abundance.
We estimate what we catch, and we've actually got an idea, because if we've got 10 bins of it and we put out an average on it, we know what's in a box, and it mightn't be right, but it's extremely close, and then we record our discards.
Scientists are aware of other inaccuracies in logbook data and often adjust for these. A common inaccuracy is position information, which is pretty easy to detect because it stands out from the rest of the fleet. There are many other examples of scientists being able to correct for inaccurate logbook data by deleting individual records that are well outside the expected range. Logbooks provide really useful information on fish with commercial value, which fishermen keep. Fish that are thrown away, however, don't usually make it into the logbook, and this is one of the reasons why scientific observers are important on boats.
We catch a lot of draft board shark and Port Jackson shark that are not commercially viable, but most of them, 99% of them are alive, so they get let go. Get a few octopus, which we keep, and a few wrasse, but not much else.
An important role for observers is to estimate the discarded catch, which is usually made up of lots of small, non-commercial species. This is important information because it gives managers a better idea of the full impact of fishing across all species. But it's not only non-commercial species that are discarded. Sometimes commercial species are discarded because there's no quota available or the fish are too small to market. In this case, good information on discards is needed so scientists can add them to the retained catch to calculate the total quantity of fish the fishery has caught. In most fisheries, it's too expensive and impractical to put observers on every boat, so only a small percentage of trips have observers. It's important to ensure that observers are distributed across the boats in the fleet to match the effort in the fishery. So, observer coverage should be highest in the areas with most fishing effort. That way, the observer's discard data can be combined with the fisherman's logbook data to provide information about the entire catch of the whole fleet. That's pretty much it for fisheries dependent data, the information collected on commercial fishing boats. Next, we'll look at fisheries independent data. This is information collected outside of normal commercial fishing operations. There's a variety of fisheries independent activities, but the main one we'll focus on is fishery independent surveys.
Sometimes you don't get all the information you need just from commercial fishing. Often we have to go outside of that and conduct other trials and surveys to collect the information we need on the fish stocks. Fishery independent surveys are one example of this. In a fishery independent survey, often the quota or the catch can be taken without worrying about the impacts of market and price and quota availability. This means that the catches are not hindered by the choices the fisherman makes about where he fishes or when he fishes and how he worries about getting that fish to market. So often these fishery independent surveys have consistent year after year areas and times when they fish, and we compare the catch rates of different species over that time. There are a number of fishery independent surveys that run around Australia, either trawl surveys or acoustic surveys that collect information that is independent of the commercial fishery.
Fishery independent surveys are often conducted with research vessels. In this way, scientists can control all aspects of the fishing trip, including location, depth, gear, fishing duration and season. Commercial fishing vessels are sometimes used, but are usually chartered so scientists can control all these variables. The main aim of these surveys is to measure a catch rate that is not influenced by market price, quota availability, targeting and avoidance. In this way, scientists get catch rate data over a number of years that can be a better measure of abundance than data collected from commercial logbooks. As mentioned at the start, a good index of abundance is a critical piece of information for stock assessments. Fishery independent survey data becomes another input into our computer model, which helps to improve accuracy.
So the fishery independent surveys give you another snapshot of what's going on in the population, and often the stock assessment will use that information alongside the commercial catch rate information to feed into the assessment. So many times you'll see that assessments are taking a variety of information, pulling it into one area and using these different sources of information to get a better understanding of the status of the stocks.
Unlike commercial fishing, fishery independent surveys need to cover the whole area of the fishery so they can supply useful information even if the fish or fishermen move around from year to year. Most importantly, they need to be conducted very consistently, year after year after year. This is because their main value is in providing a relative measure of abundance that can be compared from one year to the next. Scientists have very strict rules that apply to fishery independent surveys so they can meet these goals. That's pretty much it for data collection. In review, we've looked at recording commercial catch information, fisheries observing and fisheries independent trawl surveys. In our next section, we're going to tie it all together and show you how the stock assessment models predict fish populations and changes in fish populations.